In this video, we're going to introduce the idea of integration by the method of partial fractions. So first, I asked you to just think about this, that if I have a function with a constant a over x plus 3 plus a constant b over x minus 3, when I add those two fractions together, I get 1 over x squared minus 9. The question is, how do we solve for a and b? Well, the first thing I think you should always hopefully look to do with fractions is get a common denominator. So think about multiplying this by x minus 3 over x minus 3 and multiplying this by x plus 3 over x plus 3. So what I get is a multiplied by x minus 3 plus b multiplied by x plus 3 all over. And if you multiply x minus 3 times x plus 3, of course you get x squared minus 9. And that's equal to 1 over x squared minus 9. Well, now if you algebraically, if you want to think about this, if you multiplied both sides by x squared minus 9, the denominators on both sides would cancel. Or you could just think, well, since they have the same denominator, the numerators must be the same. So I'm just going to erase this, okay? Because I know that a times x minus 3 plus b times x plus 3 must be equal to just 1. Well, now you have to pick some x's. And you could pick any x's you want. You could pick 0 or 1 or 2 or whatever. And because we have two unknowns, a and b, you would have to pick two x's. So for instance, let's say you picked 0. Let's say you said x equals 0. That means that if I plug that in, I get negative 3a plus 3b equals 1. And then let's say, well, okay, x equals 1. And the reason, again, you need two equations is because you have two variables you're solving for. Negative 2a plus 4b equals 1. And now you could use your Algebra 2 skills, do linear combination or substitution or something, and solve for those. But because we get to pick our x's, I think there's a much easier way to do this just based on picking the correct x's. Okay? So let's just think about this for a second. If I picked, let's say, x equals 3, well, that entire first part would be 0 because it'd be 3 minus 3, so 0 times a. And this next part would be b times 6 equals 1. We'll divide both sides by 6. b is equal to 1/6. I'm just going to go up here and write 1/6 right here for b. Well, along the same lines, let's pick negative 3. Negative 3. So we get a multiplied by negative 6 equals 1 because that second part would cancel out. And we divide both sides by negative 6, so a is equal to negative 1/6. So let me go up here and write that down. Now, if you're thinking, well, okay, what does that do for us? Because we're so used to putting fractions together, what good is it to split them apart? Well, let me show you on the next slide. Let's say we were asked to integrate 1 over x squared minus 9. And let me just fill in again that this was negative 1/6 and this was positive 1/6. We solved for that. This is something that I can't integrate with methods I know right now. Usually with fractions we think of maybe a substitution. We say, well, if I made u x squared minus 9, then du would be 2x. But unfortunately, that's not going to help us. I don't have a 2x or an x to work with. So this is out. I can't do substitution, which leads me then to using this fraction split that I did. I could rewrite this integral as negative 1/6 over x plus 3 plus positive 1/6 over x minus 3 like that. Because I found on the previous slide that those two fractions added together are equivalent to 1 over x squared minus 9. Well, now I could go even further, making this look a little easier. I could integrate negative 1/6 over x plus 3 dx plus the integral of 1/6 over x minus 3 dx. I'm going to pull my constants out front. just leaving a 1 up top. And the antiderivative of 1 over x plus 3 is the natural log of x plus 3. The antiderivative of 1 over x minus 3 is the natural log of x minus 3. And that's it. This is our solution. Now, I want to briefly talk about some different ways you might see this. 1/6, first of all, a lot of times you'll see this written with absolute values. That's just kind of a nod to the fact that we do have some domain issues dealing with natural log. We can't take the natural log of a negative. Okay. These numbers out front, these coefficients, remember, can be written as powers. They could be brought in. You could have a negative 1/6 right here. And this one could be brought in and have a 1/6. That's a root. It's the 6th root. When you add logs, you're multiplying the expressions inside, so you may actually see that multiplied out. I'm not really focused on that right now. I just wanted to show you how to get the integral, but it's important to know that you could do some log reducing here, and that's all algebra. Okay, the calculus part of this is pretty easy. The algebra part, simplifying at the end, may be tricky. Let's do one more from beginning to end. So x plus 5 over x squared plus x minus 2. And again, I think the first thing I would always start with is just the question, would substitution work? And the reason I say that, because despite the fact that partial fractions are pretty easy, substitution is faster and easier if you can use it. But unfortunately here, if I make u the denominator, then du is 2x plus 2, and I certainly don't have that or any kind of multiple of that. So once again, I see that substitution is not going to work for me. So then I have to factor the bottom. Well, it would factor to be x plus 2 and x minus 1. So I put an A, B, like that. Set that equal to x plus 5 over x squared plus x minus 2. I'm going to multiply the A fraction by x minus 1 over x minus 1. Multiply this by x plus 2 over x plus 2. So I now have A multiplied by x minus 1, plus B multiplied by x plus 2. And remember, the denominators are now the same. So I'm just going to kind of ignore them and just work with the numerators, okay? So first, let's pick x to be 1. Again, the reason I picked that is because then that first part will cancel. It'll be a times 0. So I'll have 3b equals 1 plus 5, so 6. Don't forget to plug 1 in every time you see x. So b is 2. So let me go back up here. I'm just going to write a 2 on top of b. Next, x needs to be negative 2. So I'd have negative 3a equals 3. So a is negative 1. That. So my original integral is the same as the integral of negative 1 over x plus 2 dx plus the integral of 2 over x minus 1 dx. So I didn't need to put that in parentheses, but okay. So I pull those constants out front. Leaves me with just a 1. Antiderivative would be negative natural log of x plus 2. I'm going to use the absolute value here. So that's how we usually would see it. And there's our solution. Again, just be aware that a lot of textbooks, a lot of people would say, well, you could bring this in and make this to the negative first. You could bring this in and make it squared. And you could do some, because they're multiplied or added, you could multiply the expressions. But again, I just wanted to kind of show you the calculus steps today. So that's the method of partial fractions.